All right, guys, so I'm here to tell you about the p-series. And this is kind of a result that we're going to get from using the integral test. And it kind of helps us answer this question. When does the series, so if you have the sum from 1 to infinity, of 1 divided by n to the p converge? And when does the series diverge? And the answer is basically, I'm not going to tell you that now, but we're going to try and figure out what are the values of p that make the series converge, and what are the powers of p that make the series diverge. Okay, and we're going to, of course, do this by the integral test. So if you want to take a look at something like, for example, the series of 1 over n. In our last video, we used the integral from 1 to infinity of 1 over n to show that that diverges. So that's the case where p is equal to 1. Well, what if we try a bigger number? What if p is equal to 2? So what if we have the sum of 1 over n squared? Well, in that case, what we do is we take the integral 1 to infinity of 1 over n squared. So we write this as the limit as sum a goes to infinity a of 1 to a of 1 over n squared. So when you integrate that, that's n to the negative 2, so we add 1 to the power, so that's negative 1 over n going from 1 to a. So that's negative 1 over a minus 1 over n, 1 over 1, my fault. So then when you take the limit as a goes to infinity, you end up just getting negative 1 over infinity plus 1, which is 1. So it converges. Great. So we know that one converges. Okay, now, what if you take a smaller value? And of course, if you have p equals 3, you're going to get the same case, right? If p equals 3, you have 1 over n cubed, which integrates to negative 1/2 times 1 over n squared, and the same thing happens. But what if you have a smaller value? What if you try, say, p is equal to, 1/2? So that would be the sum of 1 over square root of n. That's n to the 1/2 power. So if you have that, what that means is we can say, okay, let's go ahead and look at the integral from 1 to infinity of n to the negative 1/2. Now again, I'm going to write this, we're trying to derive a rule. I'm going to write this as a limit as a goes to infinity of integral 1 to a of n to the negative 1/2. So when I add 1 to that power, I get n to the 1/2, put a reciprocal in front, and then that goes from 1 to a. So as I go ahead now and take that limit as a goes to infinity, we get 2 square root a minus 2 square root 1, which ends up being 2 square root of infinity minus 2, which is, of course, infinite, which means that this guy diverges. Okay, now, if you want to do some more of these on your own, you can. You could try p equals 0.99, p equals 1.01, and those will kind of show you the pattern. But what happens is that 1 turns out to be the cutoff. And if you pick any number bigger than 1, you get a series that converges. Any number less than 1, it diverges. If you don't believe me, just keep trying a bunch of these with the integral test and you'll see. So the p-series rule is that if you have the sum of 1 over n to the p, this series will converge whenever that exponent, that p value, is bigger than 1. It diverges whenever that power, that p value, is less than or equal to 1. And this is a rule. This is a well-known rule which you can use as a big shortcut. So you don't actually have to use the full integral test if you get a p-series. So if you're faced with a question on the AP test or my test or whatever that basically just says, does the series, from 1 to 1 to infinity of 1 over, n to the 5/2, or let's say the 5 power, converge or diverge, you don't really have to do any work. You just say, okay, this is a p-series, my p is equal to 5, that's a number greater than 1, so it converges. You don't need to do the integral test. Now, you can, of course, but you don't have to. Same thing. If someone gives you, the series, let's say 2 to infinity, if you haven't figured out the lower number doesn't really affect much in terms of convergence, of 1 over the 4th root of n. Well, what you want to do is write that as n to the p. So write the 4th root as 1 over n to the 1/4 power, and then you see, hey, again, this is a p-series. Now I have a p is equal to 1/4. That p value is smaller than 1, so of course that tells you that it diverges, smaller than or equal to 1. If you have, for example, the series, n equals 1 to infinity of 1 over n times square root of n, actually we could do a 4. The number on top doesn't matter because you can also pull it out in front, so it's 4 times the series of 1 over n squared n. Anyway, so when you deal with something like that, that's n to the 1 times n to the 1/2. So if you add those powers up, this is just the sum of 1 over n to the 3/2. And again, this is a p-series. My p is 3/2. My p value is greater than 1. So that tells us we know that this series converges. Okay, and those are the main questions with this. Now, there's certainly some you have to use the integral test for, but if you ever run into one of these where you have like a series of 1 over n to the p, just smile, use your p-series rule, and you're good to go. Okay, bring me questions to class. Thanks for watching, guys.